Hi everybody, so in this video we're going to keep talking about Gaussian reduction. We're going to do one more example of just solving a system using Gaussian reduction, and then we're going to do some application problems. Okay, so this is our problem where we're going to use Gaussian reduction to solve. Okay, so here's our system of three equations with three variables. Okay, and I'll just remind you of the process. So we're going to pick a pair of equations and eliminate one variable. Then we're going to pick a different pair of equations and eliminate the same variable. Okay, that will leave us with a system of two equations and two variables, which we'll solve, and then we'll use our answer to find the value for the last variable. Okay, so while I'm looking at this, what stands out to me is that in the first equation and the last equation, I have negative 2y and positive 2y. Okay, so I'm going to choose to eliminate y. Okay, and I'm going to do it in those two equations. Okay, so remember, you're just choosing them by what's going to be the most efficient, the easiest. Okay, so why not pick two equations that are already set up for elimination? Okay, so I'm just going to copy down both equations. Okay, and then my third equation. Okay, and now I'm going to add these together. Okay, so x plus negative 3x is negative 2x. Negative 2y plus 2y is 0. 3z minus 2z is 1z. Okay, and 7 plus negative 10 is negative 3. Okay, so this is what would be my fourth equation, and you can see that it only has x and z. Okay, so now I'm going to look back and try to find another pair of equations where I can eliminate y. Okay, so since I've already done 1 and 3, I can do 1 and 2 or 2 and 3. Okay, this is going to be really similar because either way I'm going to have to multiply this equation by either 2 to eliminate here or negative 2 to eliminate here. Okay, so I'll just pick 1 and 2. So again, I have to eliminate y. Okay, and I'm going to do that in equations 1 and 2. Okay, so I'm just going to copy my first equation. So that's x minus 2y plus 3z equals 7. Okay, and then I'm going to take my second equation and multiply it by 2. Okay, so you guys can't see that, but it's 4x plus 2y plus 2z equals 8. Okay, and now I'm going to add these together. So this is going to give me 5x, that's 0 as intended, and this is 5z equals 15. Okay, and that's going to be my equation 5. Okay, so now you can see these two equations do have just two variables. Okay, so we're going to solve that like we normally would. Okay, so I'm going to copy those two equations down. Okay, so my equation 4 was negative 2x plus z equals negative 3. And my equation 5 was 5x plus 5z equals 15. Okay, so I'm going to go ahead and multiply my top equation by negative 5 so that I can eliminate my z's. Okay, so this will be 10x minus 5z equals 15. Okay, and then here I'm going to just copy it down. So I'll have 5x plus 5z equals 15. Okay, so I'll add them. 10x plus 5x is 15x. Okay, negative 5z plus 5z is 0, which is what we wanted. 15 plus 15 is 30. Okay, and this gives me x equals 2. Okay, so now that I have my value for x, I'm going to use one of these two equations to find my value for z. I think that will be a little bit easier in equation 4. Okay, so I have negative 2x plus z equals negative 3. Okay, so negative 2 times 2 is negative 4. Okay, and this gives me z equals 1. Okay, now the last thing that I need to do is to find the value for the very last variable, okay, which is y, okay? So I'm going to pick from my original equations, the ones that have 3 variables, one that I think is going to be easy to find the value of y. So I'm going to choose equation 2, okay, and I'm going to plug in the values that I have for x and z, okay? So I had 2x plus y plus z equals 4. Okay, so this is going to be y plus 5 equals 4. So y is negative 1. Okay, and then I'm not going to forget to write my answer as an ordered triple. So x, y, z. Okay. All right. So hopefully that helps you understand how to do these problems once you have the system of equations. So let's look at some applied examples where we're going to have to write the system of equations. Okay. So this one says, when a child breaks open her piggy bank, she finds a total of 64 coins worth $6. There are only quarters, nickels, and dimes. If the nickels were dimes and the dimes were nickels, they would be worth $5. How many of each type of coin is there? Okay. We are going to, first of all, write down what variables we're going to use. Okay. So I'm just going to use Q for the number of quarters. Right? It says how many of each type of coin. So we know that we're asked about those 3 types of coins. So N is going to be the number of nickels. Okay, and then D is going to be the number of dimes. Okay, you're welcome to use X, Y, and Z if you prefer, but this seems really natural given the problem. Okay, all right. So the first thing it says is that there's a total of 64 coins. Okay, so I'm going to use this information, okay, to say that if I added the number of all the coins together like this, okay, I should get the total number of coins, which is 64. Okay. Then I'm going to focus on the value of them, okay? So it says they're worth $6. Okay, so what I'm going to do is write an equation about the value. Okay, so each quarter is worth 25 cents. Okay, times the number of quarters, which is Q. So that will give us the value of all the quarters. Then I could do 0.05 times the number of nickels, and that will give me the value of each of all of the nickels together. Then I'll do the same thing for dimes. Okay, 10 cents per dime times the number of dimes, and this will give me the value for all of the dimes. Okay, so this is the value for all the quarters, all the nickels, and all the dimes. So if I add them together, that should be the total value, which is $6. Okay. All right. Now the thing that's most confusing about this problem is this sentence here, okay? If the nickels were dimes and the dimes were nickels, they would be worth $5, okay? So what they're trying to explain is if instead of N nickels and D dimes, you had D nickels and N dimes, it would only be worth $5, okay? So we're having the same number of quarters, okay, with the same value, okay? But now, instead of having N nickels, we have D nickels. Okay, that's what they're describing. Okay, and instead of having D dimes, we have N dimes, right? The number of coins is switched between the nickels and dimes. Okay, and that would be worth $5. Okay. All right. So I'm going to give you guys some advice about how to solve this. Okay. If you're solving this by hand, okay, my first advice would be to multiply both of these equations by 10 or maybe even 100. Okay. So you would get this equation looking the same. Okay. All right, then you would multiply this by 100 to give you 25Q plus 5N plus 10D equals 600. Okay, because that's oftentimes easier to solve by hand, like if you don't have a calculator. And then the last one, I would not only multiply by 100, but I would rearrange the terms so that they're in the same order as the other ones. So I would have 25Q plus 10N plus 5D equals 500. Okay, and that's the first thing I would do in order to solve this. Okay, all right, so I'm going to encourage you guys to solve this on your own. Okay, and I will give you the answer. Okay, is that there's 20 nickels. Okay, 40 dimes. Okay, and 40 quarters, or 64 coins. So this would make 60 coins. There's only 4 quarters. Okay, so if you are practicing this at home, this is the answer that you should get. If you have any questions about that, or if you can't get that answer, feel free to email me or to ask me in class. Okay. All right, let's look at our next word problem. Okay. It says, the owner of a candy store wants to mix lollipops worth $3 a pound, caramels worth $9 a pound, and chocolates worth $9 a pound to get 50 pounds of a mixture worth $6 a pound. Okay, so a lot of information in there. All right. She uses 15 fewer pounds of caramels than lollipops. How many pounds of each kind of candy should she use? Okay, so the first thing we're going to do is set up our variables. Okay, so it says how many of each candy. Okay, so I'm going to use L for lollipops. Okay, I'll use C for caramels. Okay, and since chocolates is also C, I'll just use H. Okay, all right. So now we're going to try to set up some equations. Okay, so first of all, it says 50 pounds of a mixture. Okay, so if this is the number of pounds, right, each of these is the number of pounds, okay, then the total, right, the 50, which is the total, should be the sum of these. Okay, so if we add these all together, this should be 50. Okay. All right. Then we're going to write, so this is an equation about weight, basically. Okay, then we're going to write an equation about cost. Okay. So the lollipops are worth $3 a pound. So if they're $3 a pound times the number of pounds, that will give us the total value of just the lollipops. Then for the caramels, we would have $9 a pound times the number of pounds, and that will give us the total value of just the caramels. Then for the chocolates, they're $9 a pound times the number of pounds, right? So that's the total value of the chocolates. So when we add these together, we should get the total value of the mixture, okay, which is $6 a pound, 50 pounds. Okay, so this is $6 a pound, 50 pounds. Okay. So we're using both of these pieces of information along with the cost of each candy, okay, to write that equation. All right. Then the last equation is going to come from here, where it says she uses 15 fewer pounds of caramels than lollipops. Okay. So the weight of caramels is 15 fewer than the amount of lollipops. Okay. If you have these reversed, you should be able to tell by doing an example, right? So for example, if she uses 25 pounds of lollipops, she should be using 10 pounds of caramels, right? 15 pounds less, okay? And you can just check that that works. 25 minus 15 is 10. Yes, so my equation is in the right order. It's a common mistake to have these reversed. Okay. All right. Now we're actually going to solve this system because it does have kind of an unusual setup. So I want to show you what we can do with this type of equation. Okay, so the first thing I'm going to do is put all of these into standard form where we have all the variables on the left and the numerical value on the right. Okay, so the first one is already in that order. Okay, the second one is close. Okay, and all we needed to do was multiply 6 by 50 to get 300. Okay, and then the last one, right, so that was the first one we just copied, the second one we multiplied this together, and here we're going to rearrange it so that everything is in the order that we think it should be in. Okay, so I want L to go first, so I'm going to subtract L from both sides. Okay, and that will give me negative L plus C equals negative 15. Okay, so I'm just rearranging that last equation so that I have something that's in the same order as all the other ones. Okay. All right. Now here, you can already see that in equation 3, there is no H. Okay. So that means I don't need to develop two equations that only have two variables because this equation already only has two variables. So what I'm going to do is take equations 1 and 2, and I'm going to eliminate H in 1 and 2. Okay. So if I look at these and I'm trying to eliminate H, I'm going to multiply this one by negative 9. Okay. All right. So I'm going to have negative 9L plus minus 9C minus 9H equals negative 9 times 50, which is negative 450. Okay. And then I'm going to just copy down equation 2, okay, which was 3L plus 9C plus 9H equals 300. Okay. So here I'm going to add them together. So negative 9L plus 3L is negative 6L. Negative 9C plus 9C is 0. Negative 9H plus 9H is also 0. And negative 450 plus 300 is negative 150. Okay. So what's happened here is because these are both canceling out, I'm able to immediately solve for my value L. Okay, so I'm just going to divide both sides by 6. Okay. So, yep, I'm just going to do 150 divided by 6 to get my answer. Okay, and that's 25. Okay. Now I have the value for my variable L. So if I look at my equations, okay, this equation only has L and C. So if I plug in my value for L, that will allow me to find my variable for C. Okay, so I'm going to plug in my value for L into equation 3. Okay, so I have negative L plus C equals negative 15. Okay, so this will give me C equals 10 by adding 25 to both sides. Okay, so now I have the value for both L and C, right? So I can plug into either one of 1 and 2 to get the value for H. Okay, just for ease, I'm going to go ahead and plug into equation 1. Okay, so I'll have L plus C plus H equals 50. Okay, so 35 plus H equals 50. And that will give me H equals 15. Okay, and now because this is a word problem, I'm not going to write my answer as an ordered triple. I'm going to write it as a sentence. Okay, so L stood for lollipops, so I would have 25 pounds of lollipops. Okay, 10 pounds of caramels, and 15 pounds of chocolates. Okay, so this one has a little bit different solving process, and it's because initially we have an equation that has 2 variables, but even more so when we go to eliminate a variable in the other equations, we end up just getting a single value. Okay, so this really throws us into back substitution mode, and you'll see that the rest of it is back substitution. Okay, versus really need to going through 100% of the Gaussian reduction method. Okay, the other thing that's important to point out is that your answer should be a sentence because you're doing a word problem. Okay, let's look at our last word problem. Okay, a manufacturer makes 3 different models of swing sets. The monkey takes 2 hours to cut the wood, 2 hours to stain the wood, and 3 hours to assemble. The orangutan takes 3 hours to cut, 4 hours to stain, and 5 hours to assemble. The King Kong takes 4 hours to cut, 5 hours to stain, and 5 hours to assemble. The company has a total of 61 cutting hours, 73 hours to stain, and 83 hours to assemble. Okay, how many of each type of swing set can they make? Okay, so the first thing we're going to do, just like any word problem, is pick our variables. Okay, so I'm going to use M for the number of monkey swing sets. Okay, now I don't want to use O for orangutan because it'll look like a 0, so maybe I'll use G. Okay, and then I'll use K for King Kong swing sets. Okay, so now in this example, we have to look at the totals that they give us, okay? And the totals were about cutting, staining, and assembling. So I'm going to write 3 equations, one about cutting, okay, one about staining, and one about assembling. Okay, and I know to do that, again, because those equations are going to correspond to the totals that they've given us. Okay. All right, so let's look at cutting. Okay, so the monkey is going to be 2 hours to cut. Okay, the orangutan takes 3 hours to cut, and the King Kong takes 4 hours to cut. So I'm ignoring all the other times and I'm only looking at the times to cut. Okay, so that's going to tell me that I have 2 hours per swing set times the number of monkey swing sets. Okay, then I have 3 hours per swing set times the number of orangutan swing sets. Right, so this is the total time that it would make you to cut the wood for all of the monkeys, for all of the orangutans, okay? And then for King Kongs, it's 4 hours per swing set times the number of swing sets, okay? So this is what it would take time-wise to cut each one of these. So the total, or the sum, right, should be the total amount of time that they have to cut. And we look at the question. It says a total of 61 hours to cut. Okay, so our total is going to be 61. Okay, then we're going to look for all the times to stain. Okay, so for the monkey, we have 2 hours. Okay, for the orangutan, we can see that we have 4 hours. And for the King Kong, we have 5 hours. Okay, so for the monkey, it's going to be 2 hours per set times the number of sets. For the orangutan, it's going to be 4 hours per set times the number of sets. And for the King Kong, it's going to be 5 hours per set times the number of sets. Okay, then the sum, or the total, is going to be whatever the total is in the question. Okay, so the company has a total of 73 hours to stain. Okay, so our total is going to be 73. Okay, and then our last equation is going to refer to the time to assemble. So we're going to look here for all the times to assemble. So for the monkey, it's going to be 3 hours. For the orangutan, it's going to be 5 hours. And for the King Kong, it's going to be 5 hours. Okay, so we're going to say for the monkey, it is 3 hours per set times the number of sets. For the orangutan, it's 5 hours per set times the number of sets. For the King Kong, it's 5 hours per set times the number of sets. Okay, and the sum total should be equal to whatever the total is here. Okay, so 83 hours to assemble. Okay, so our total is going to be 83. Okay, so now we have 3 different equations. They all have each of the 3 variables. It's set up for you naturally to use Gaussian reduction here. Okay, so I'll let you guys go ahead and complete that on your own. Let me look if I do have the answers to this. I don't think so. No. Okay, so if you do this on your own and you have any questions, again, feel free to let me know, but otherwise I will see you guys soon.